Hey guys, just want to do a quick review before you go into your equilibrium assessment, which is on CASA Learning. All right, so again, just to review a little bit, two definitions of chemical equilibrium: concentration of the reactants in the products are constant, and the rate of the forward reaction is equal to the rate of the reverse reaction. Don't forget, in addition to chemical equilibrium, you could also have phase equilibrium. All right, we have our three stresses: changing temperature, concentration, and pressure. For pressure, please make sure that everything in the reaction is in the gas phase. One of the questions from lesson 3 that you put your answers in the Google Doc. One particular question, a lot of people did not realize that there was a solid in the reaction. So if you change the pressure, that's not going to change anything. The shift is how the reaction responds, pushing towards the right or towards the left. So temperature, this was our first stress. Increasing the temperature favors the endothermic reaction. So you have to find that endothermic direction. In this case, the heat is on the reactant side, so going forward, that will be the endothermic direction. Reverse will be the exothermic. So whenever you increase the temperature, you're going to shift to the opposite side. You're going to shift away from the heat because that will always be the endothermic direction. When you decrease the temperature, you favor the exothermic direction, which is going towards the side that the heat is in. Concentration is basically adding or taking away a substance. So when you increase the concentration, you will always shift to the opposite side. So we put the phrase up and away. If something goes up, you shift away. So if I increase the concentration of A, the reaction shifts to the opposite side. If I increase the concentration of C, the reaction shifts back to the left side there. Okay. And decreasing the concentration, if you take something away, it shifts to that side where the decrease was in an attempt to replace whatever was removed. And lastly, we have pressure. Pressure, everything has to be in the gas phase. As soon as you see something as a solid, a liquid, or aqueous, the reaction will not be affected by the pressure. So if you increase the pressure, you shift to the side that has less moles of gas. All right, and you figure out the moles of gas by the coefficients. So on the left-hand side here, I have 5 moles of gas. I have 2 plus 3. And on the right side, I have 3 moles. So if I increase the pressure, this reaction will shift or push towards the right-hand side, the product side, and make more of whatever's on that side. If I decrease the pressure, it's just the opposite. It shifts to the side that has more moles. If the moles are equal, there is no effect from the pressure. And again, the other time you could get no effect is when something here is not in the gas phase. Catalysts, they don't do anything. All right, they do not do anything towards equilibrium. They only affect rates of reaction. The last part to this is what happens. We talked about, remember, we said there was 3 things. Number 1, the stress. Number 2, the shift. And then number 3, what happens because of that shift? So if I am shifting to the right, what that means is we are making more or increasing the concentration of C, and we're going to do that by using up A and B and decreasing the concentrations of those. So that's that third part that we can't forget, that when you do that shift, it means you're pushing the reaction in one way or the other, and you're either making more of whatever side you shift towards, and in order to do that, you're going to have to use up whatever's on the other side. Okay, so again, if I do something to make this reaction shift to the right, that means I'm going to increase the concentration of C, and the concentrations of A and B are going to decrease. All right, and that's the last of that. So now real quick, if you take a look at this page in the note packet, this is just another set of practice problems. I want to go through these. You can press pause real quick and try to answer these questions here. So the first one, we have the reaction to make ammonium, NH3. In order to make more, what changes could push this reaction to make more? So basically what this is it's telling you we want this reaction to shift to the right? Okay, what will you do to get that reaction to shift to the right? And at the bottom, they're asking you shift left or right. Okay, so you can press pause and complete these questions and then check back. Okay, so for this first one, all right, what changes are going to make this reaction make more? So we want to figure out which of these changes will result in more of that NH3 being made. So the first one, we have an increase in temperature. Okay, increase in temperature favors endothermic. Well, here's my heat on the product side. That forward reaction is exothermic. Okay, so increasing the temperature will actually result in a shift to the left. All right, since this forward reaction is exothermic, and the reverse reaction will be endothermic. All right, an increase in the concentration of NH3. Well, NH3 is over here. If we increase the concentration of this, I'm going to push that reaction again to the left. All right, so that is again going to shift away from that right side. And letter C, an increase in pressure will result in a shift to which side? Well, I have 1 plus 2 moles. I got 3 moles of gas on the left, and I got 2 moles of gas on the right. So if I increase the pressure, the rule is you shift to the side with less moles of gas. That will result in a shift to the right side. Okay, so that's going to be what causes the reaction to make more NH3, to shift to the right. Now at the bottom here, how would the reaction shift if if I decrease the concentration of CO, if I took some of this away, the reaction will shift to that side to replace what was taken away. So that'll be a shift to the right. If I increase the concentration of Cl2, if I increase the concentration, we shift to the other side because now I have more over here to react. It's going to push towards the other side. That would result in a shift towards the left. Decrease in pressure. Well, everything here is a gas. I have just 1 mole of gas on the left, and I have 1 plus 1 for 2 moles of gases on the right. So a decrease in pressure, be very careful, will shift to the side with more moles. So that'll be to the right. And then increasing the temperature favors the endothermic reaction. Well, here's my heat. It's on the left side, so the forward reaction is endothermic. So increasing the temperature results in a shift to the right. All right. And then finally, if the reaction shifts to the right, what would happen to the concentrations of Cl2 and COCl2? Well, again, if you shift to one side, you make more of whatever's on that one side. Okay, so if we shift to the right, I'm going to make more of the CO and the Cl2. So the concentration of Cl2 will increase. But because I'm shifting to the right side, I have to use this up. All right, that's going to react in order to give us this. So the concentration of the COCl2 will decrease. All right, so that's your last little bit of review for Le Chatelier's and the introduction to equilibrium. You're going to take the equilibrium assessment that's posted on CASA Learning, and then there's going to be some additional assignments for Thursday and Friday, and then we'll get back into the rest of the notes on Monday. Okay, and we'll be wrapping up the rest of the topic on Monday. We don't have that much more to go yet. All right, guys, there you go. If you have any questions, let me know, but everything is posted for you online. All right, have a great day. Bye.